In the vast theater of space, our sun is both a life-giver and a potential threat, a cosmic powerhouse that shapes the very conditions for life on Earth. Its energy sustains our planet, but its unpredictable outbursts can also send shockwaves through our technological world. On December 1st, 2025, NASA and NOAA detected a massive eruption on the sun, a coronal mass ejection, or CME, headed straight for Earth. This CME is a colossal cloud of charged particles, ejected at millions of miles per hour, carrying with it the potential to disturb our planet's magnetic field. The discovery triggered an urgent alert. Scientists quickly realized that a significant solar storm was on its way, expected to hit Earth around December 3rd or 4th. The world's space agencies began monitoring the situation around the clock. While classified as a G2, or moderate geomagnetic storm, moderate in space weather terms still means serious business for our technology. Even a G2 storm can cause fluctuations in power grids, impact navigation systems, and create dazzling auroras far from the poles. Think of it as a powerful cosmic wind about to buffet Earth's magnetic shield, a force that can ripple through our atmosphere and affect systems we rely on every day. The storm won't harm people directly, but it could disrupt the technological web we depend on. Satellites, GPS, radio communications, and even the stability of our power grids could be at risk. Thanks to decades of solar observation and a fleet of spacecraft constantly watching the sun, scientists can now track these storms and forecast their arrival with impressive accuracy, giving us a chance to brace for impact. This early warning gives us a crucial window to prepare, allowing engineers to safeguard satellites, power companies to adjust operations, and emergency services to be on alert. As we await this event as well, it's still a powerful reminder of the sun's immense energy and our vulnerability in the face of nature's cosmic forces. The beauty of the auroras comes with a price. The Sun-Earth connection is more complex and volatile than most realize, with invisible threads of magnetism and energy constantly weaving between our worlds. This storm is a test of our ingenuity in the face of cosmic forces, a challenge that pushes us to innovate, adapt, and deepen our understanding of the universe we call home. To grasp a solar storm, picture the sun as a churning sphere of plasma, a gigantic ball of superheated gas where temperatures soar into the millions of degrees. The sun is far from calm. Its surface is in constant motion, with boiling plasma and swirling currents that create a dynamic, ever-changing environment. Deep within, its magnetic fields twist and snap like overstressed rubber bands, building up tension over days, weeks, or even months. These invisible magnetic forces are incredibly powerful, shaping the sun's behavior and driving its most dramatic outbursts. When these tangled fields suddenly reconnect, they unleash a torrent of energy, one of the most explosive events in our solar system. This sudden release can be millions of times more powerful than a volcanic eruption on Earth, sending shockwaves rippling through space. This process, called magnetic reconnection, hurls billions of tons of solar material into space at over 1 million miles per hour. These massive eruptions are known as coronal mass ejections, or CMEs, and they can stretch for millions of miles as they travel outward from the sun. A solar storm isn't wind and rain, but a surge of charged particles and magnetic fields racing across space. These storms are made up of high-energy protons and electrons carried by the solar wind, and they can travel all the way from the sun to the edge of our solar system. When Earth is in the path, our magnetic field takes the hit. The impact can trigger geomagnetic storms, which can disrupt satellites, power grids, and even navigation systems. These storms follow the solar cycle, an 11-year rhythm of rising and falling activity. During the solar maximum, the sun is at its most active, with more sunspots and eruptions. As we near solar maximum, eruptions become more frequent and intense. The sun's surface is peppered with sunspots, each a potential source of powerful flares and CMEs. Sunspots multiply, and the odds of major flares and CMEs increase. The more active the sun, the greater the risk of solar storms reaching Earth. We're currently approaching a solar peak, which is why storms like this are becoming more common. Scientists around the world are on high alert, monitoring the sun's every move. Solar storms are the sun flexing its magnetic muscles, a natural part of its life cycle. These outbursts are reminders of the immense power at the heart of our solar system. For most of history, these events went unnoticed, except for mysterious lights in the sky. The auroras, dazzling displays of color, were the only clues to the sun's hidden fury. Today, our technology makes us acutely aware and vulnerable. Satellites, airplanes, and even astronauts in space can be affected by these storms, making space weather a real-world concern. Understanding solar storms is the first step to protecting ourselves. By studying the sun, scientists hope to predict these storms and minimize their impact on our modern world. The sun's tantrums are now a global concern, reminding us that our planet is just one part of a much larger and sometimes volatile cosmic neighborhood. Solar storms come in several forms, each with unique impacts. Solar flares are intense bursts of radiation, reaching Earth in just 8 minutes and causing brief radio blackouts. The recent flare on December 1st triggered outages in Australia and Southeast Asia. While flares can't harm us on the ground, they disrupt communications and pose risks to astronauts. The real threat is the CME, a massive cloud of plasma that can reach Earth in hours or days, driving geomagnetic storms. CMEs can damage satellites, disrupt GPS, and threaten power grids. Solar radiation storms, another component, send high-energy particles toward Earth, endangering satellites and polar flights. These storms funnel particles toward the poles, sometimes forcing airlines to reroute. Each outburst is a reminder of the sun's unpredictable power. When a CME hits, Earth's magnetosphere shields us, but not our technology. The storm energizes the ionosphere, disrupting radio and GPS signals. Satellites face increased radiation and atmospheric drag, risking damage and shortened lifespans. Power grids are especially vulnerable. Geomagnetically induced currents can overload transformers and trigger blackouts. Even a moderate G2 storm can cause communication glitches and force satellite operators to take precautions. Airlines may reroute flights, and GPS accuracy can falter. Our interconnected world is more exposed than ever. The storm is a wake-up call for our digital infrastructure. We must prepare for the sun's next move. Our technology's Achilles heel is exposed by space weather. Solar storms aren't just threats, they create beauty too. When the sun sends charged particles hurtling toward Earth, the results can be both mesmerizing and dangerous. The aurora, or northern and southern lights, are vivid displays caused by solar particles colliding with our atmosphere. These lights shimmer and dance in the sky, painting it with brilliant greens, purples and reds, captivating anyone lucky enough to witness them. During strong storms, auroras can be seen much farther from the poles, dazzling people in unexpected places. Imagine looking up from your backyard and seeing the night sky ablaze with color, even in regions where auroras are almost never seen. But history warns us. In 1859, the Carrington event unleashed auroras as far south as Cuba and Hawaii, places that had never seen such a spectacle before. The skies glowed so brightly that people could read newspapers at midnight, but the beauty came with a price. Chaos on telegraph systems across continents. Wires sparked, paper caught fire, and messages sent themselves. Operators were shocked, literally, by the sudden surges of electricity. If a storm of that magnitude struck today, the damage to our power grids, satellites, and communication networks could be catastrophic, disrupting daily life on a global scale. The aurora is a beautiful reminder of the sun's power, an awe-inspiring phenomenon that connects us to the cosmos. But it's also a warning of the sun's potential for destruction, a force that can disrupt our modern world in an instant. Our modern world is far more vulnerable than in 1859, with technology woven into every aspect of our lives. The stakes are higher than ever, and understanding these storms is more important now than at any point in history. We're not helpless. Space weather forecasting is now a reality. NASA and NOAA use a fleet of spacecraft to monitor the sun around the clock. The Solar Dynamics Observatory captures high-def images, while SOHO and STEREO track CMEs in real time. The Parker Solar Probe ventures closer to the sun than ever, sampling the solar wind directly. Data streams to Earth, where scientists issue alerts and forecasts. These warnings help satellite operators, airlines, and power grid managers take protective action. Every minute of warning counts. Forecasting space weather is a triumph of human ingenuity. This G2 storm is a timely reminder. Our technology is at the sun's mercy. Better forecasting means more time to protect satellites, reroute flights, and safeguard power grids. Scientists are working to make our infrastructure more resilient, developing robust transformers, radiation-hardened electronics, and smarter response systems. As we look to a future with lunar and Martian settlements, understanding space weather becomes even more critical. The sun's cycles will continue. Our vigilance must too. Adapting to our cosmic environment is our next great challenge. The story of humanity is one of adaptation. Our survival depends on learning from and preparing for the sun's next move.